My name is Scott Clark. I'm an assistant professor in geology, and the course we're talking about is Geology 106, Earth Science. The lecture we filmed was an introduction to Earth's interior, and that is a stepping stone to talking about plate tectonics, which is a key feature of the geology side of the course. And we looked at what the layers are inside of Earth, what they're comprised of, and importantly, how do we know any of that? Because we can't go down inside the Earth to study what's in there, so we need to use other means to understand what's going on inside of the Earth. And so we talked about how we use earthquakes and seismic waves that are generated by earthquakes, and how we use meteorites that come to Earth, and use both of those to understand what the layers are and what they're made of. Tectonics is considered the unifying theory in the geosciences. It explains so much about what we see on Earth. It's an incredibly powerful theory. And it didn't come together, the pieces didn't come together until the 1960s and early 70s. But since then, we can use plate tectonics to explain a number of features you see on Earth. For example, if you've heard of black smokers, which are chimneys where you have black material coming out of the ocean floor into the deep ocean. They frequently occur close to plate boundaries. Plate tectonics can explain why we have these black smokers, these chimneys down in the middle of the ocean basins. Plate tectonics can explain why we have the Himalayas between India and China. They can explain why we have the volcanoes that we do and why those volcanoes occur where they occur. Can also explain the Appalachian Mountains. I would like them to take away content knowledge as a key thing. These are future teachers, and they are going to be teaching students at a critical point in those students' lives. They're teaching students who are being exposed and very excited about everything they're learning to. They're being exposed to science for the first time, maybe. And so if these teachers have a good content knowledge, they're going to be able to pass that on to many future generations of students. I would like them to appreciate the evidence-based nature of science. When we go on our field trips, I just mentioned earlier that we had mountains here a long time ago. Well, what's the evidence? Is it just me saying, oh, we had mountains? Or can we go to Eau Claire River and look at rocks there in the riverbank and say, well, did these rocks form here at the surface? Could they have formed under these conditions, or did they require other conditions? If so, what were those conditions, and how did these rocks go from where they formed to being up here on the surface? So I'm looking for them to understand that we use evidence and observations. And then I also want them, by the end of the semester, to have a certain level of self-confidence, so that when they're talking to friends, colleagues, or listening to things on the news and they hear something related to earth science, they can say, wait, that doesn't make sense, and I can figure out why, or I understand why that doesn't make sense. And the last thing I want them to take away is an appreciation that not just as teachers, but as citizens of our planet, that their lives and Earth and Earth processes are very much interconnected. Here in western Wisconsin, we have frac sand in the news a lot. So we talk some about frac sand, we see how that's connected to them. We talk about issues like levees. So we have levees right beside rivers. You know, are the levees being maintained, or are they allowed to fall apart? What can happen if something happens to those levees? We spent a lot of time on the theory of plate tectonics, so that theory is incredibly powerful for understanding how the Earth works. Well, another thing that's been in the news a lot lately are earthquakes in Oklahoma. With the theory of plate tectonics, does it make sense that those earthquakes are naturally occurring, or do we need some other explanation, possibly like injection of fluids deep underground, which are lubricating faults, and that's why they're getting earthquakes? And if they can take the appreciation that so much of their lives is interconnected with Earth, then I think we've done our job.